Inge ma screen connect agala.
Kamraj. Hello.
So Dean AC and RI Madurai, can you able to hear me? So you want to check the audio and video?
Hello sir, AC and RI Madurai
Second auditorium, somebody is there?
Sir, AC and RI Madurai audible sir?
Sir, audio is clear sir. From Curriculum campus, audio is clear sir.
So video on பண்ணுங்க Madurai.
Sir, on பண்ணிருக்கோம் sir.
யாராருங்க already who are all available now? One. Sir, please tell which are all the campus now available online, video on. Ichangote is there. AC and RI Ichangote.
Good morning.
Sir, good morning sir.
Good morning. கேக்குதுங்களா? நல்லா எக்கோ
Sir,
அடிக்குதா?
Velayadam sir, good morning.
Yes, good morning. கேக்குதுங்களா?
I couldn't hear you.
Hello. Hello. கேக்குதா? Hello.
Ichangote, I could not connect your speaker sir.
ஸ்பீக்கர் கனெக்ஷன்ல தான் கனெக்டட் தான். கேக்குதா இல்லையா?
Anyway, within another 3 minutes, we are going to start the session. Please check all your another Ichangote.
செந்தில் கேக்குதா இல்லையா? ஹலோ ஹலோ
AC and RI Kilikulam. AC and RI Kilikulam.
Sir?
Is audible?
Yes sir, is audible sir.
Slides visible?
Slide visible agala sir. Okay. It's okay sir.
செந்தில் கேக்குதா? ஹலோ
Yes sir, you are audible
Kilikulam,
sir.
please.
ஹலோ
Yes sir, Ichangote audible
Other
sir.
campuses.
ஓகே ரைட்.
Valavichanur. Kilikulam, I could not hear you. Ichangote, I could not connect you. Madurai, no response. Trichy, no response.
Sir, AC and RI Madurai audible sir? AC and RI Madurai.
Yeah, now I am seeing the screen Madurai. I think Kamaraj is login.
Yes sir. Dr. P. Kamaraj.
This is from
Please test your audio, Kamaraj.
Sir, your voice audible sir.
This is from AC and Ichangote. Is it audible? Hello. Hello.
Yes sir, your voice
Sir,
audible.
sir, கேக்குதா?
நான் பேசுறது கேக்குதா?
Yes sir, audible இருக்கு sir.
இல்ல அவர் டீன் எஸ்பிஜிஎஸ் கேக்குறேன். He is
Message கொடுங்க. Text message
Sir,
கொடுங்க.
Ichangote audible sir.
Sir, if any issues
Sir,
are there, please
audible,
text
sir.
the message, sir.
வனிதா உங்க
Chat
டீன் தான்
box, put the message.
இல்ல Ichangote audible தான் sir, no
Okay,
problem
okay.
sir.
Vanitha, I couldn't hear you.
Sir, Ichangote audible sir.
ஓகே வனிதா, thank you.
Vanitha ma'am?
What about Kilikulam?
Kilikulam Stephen sir.
Madam is
Stephen sir.
audible?
Yes sir,
Sir, AC
audible
and RI
sir.
Kilikulam, please.
Okay sir.
AC and RI Kilikulam. Phone la கூப்பிடுங்க course campus க்கு. Call Kamaraj. AC and RI Kudumiyan Malai, please respond. AC and RI Kudumiyan Malai. So now time's up. So today we will start the lecture. I hope you are all hearing the voices. So anything you call me, call and any issues are there, please call by mobile. Let us start the lecture. It will be a 40 minutes presentation. Then last 10 minutes we have discussion. Now I invite the form machinery and power speaker will start the lecture. Thank you.
So good morning to all. So today we are going to see the working principle of internal combustion engine, two-stroke, four-stroke engine, and then application comparison between the two-stroke, four-stroke, and what are the terminology related to the engine components. As you know, the engine is a most important prime source or a prime mover and a power source, which is used every section of life. If you want to do any work, we need a power. So it can be retrieved or it can be get from the different kind of source of energy. Among the different kind of source of energy, engine is the one of the power source. So if you are talking about engine, it is the example of heat engine. So whenever we want to do some work, we need to spend some kind of energy. So the rate of doing work, we will call it as a power. So the same way, the engine can deliver a certain sort of power by the way of converting certain kind of energy. For in case, if you are considering an engine, suppose for example, if we are using two-wheeler, four-wheeler and tractors, those kind of vehicles, the power is converted into, the thermal power is converted into mechanical work. So initially we are supplying the fuel inside the engine. The fuel is burned with the help of ignition. Then that will be converted into thermal energy. Again, the thermal energy converted into mechanical work. So thereby we are doing different kind of activity in agricultural. If you are taking as a heat engine, so heat engine is nothing but it is a machine. It will convert the chemical energy into thermal energy. Again, the thermal energy converted into mechanical energy. So for doing this particular operation, there will be a different kind of component involving in the engine, such as cylinder, piston, connecting rod, crankshaft, camshaft. So those things we are going to later, we will see all the individual component. So heat engine is a machine for converting heat that is developed by the burning of fuel that will be converted into useful work. So if you are seeing this figure, so there is a burning gas below that particular component. So here the water is converted into steam. The steam has more energy when compared to water. So it will try to push the piston towards the flywheel or a crankshaft. Then thereby we are getting some kind of mechanical work. So the fuel energy converted into chemical energy, the chemical energy converted into thermal energy, the thermal energy converted into mechanical work. So this is the basic principle about the heat engine. So this is one of the example of external combustion engine. So if you are seeing here, the ignition, the burning will be happen outside of the cylinder. The inside there will be a steam or there will be a air. So when the air or steam getting energy, it will try to expand. So as we know, according to the gas law, when you are burning some sort of air or gas, it will try to expand. So such a way that we are pushing this piston, then thereby we are getting rotational movement. So the linear movement converted into rotational movement, thereby we are achieving all kind of activity. For the power is moving towards gearbox, then it is moving towards differential, then finally it will reaching to drive wheel. So the wheel will make the rotational effect, thereby we are pulling some kind of load, or we will transporting some sort of goods into somewhere. So thereby we are getting power. So again, if you are considering the thermal energy, so it is not all 100% of thermal energy converted into useful work. Some sort of heat will be lost due to friction, due to loss due to the exhaust gas, and some sort of gas due to the radiation, and again some sort of thermal energy moving into conduction. So thereby different kind of component will be separated. by the main thermal energy. So in this device, the high temperature heat produced by the burning of fuel is partially converted to mechanical energy to do work, and the rest is rejected into the atmosphere in terms of smoke. So whenever the engine is working in anywhere, we can witness that there is some kind of smoke with the presence of heat. So thereby we are wasting some sort of heat energy. Okay. So there is no 100% of conversion of heat energy into mechanical work. Okay. Then come into the different type of engines according to the operation, according to the usage of fuel, according to the stoke. So that we can classify different kind of engine. So first thing, based on combustion of fuel. So where the fuel is being burned, whether it is inside the cylinder or outside the cylinder. So thereby we can classify external combustion engine. Another one is internal combustion engine. So for the best example for the internal combustion engine is steam engine. So there we are burning the gas outside of the cylinder. Then the gas is expanded or converted into steam. Thereby we are achieving some kind of mechanical work. So the combustion uses the heat in the form of steam, which is generated in a boiler, placed entirely separate from working cylinder. Then that will be converted into mechanical work. The best example for the external combustion engine is steam engine. Okay. So next one is internal combustion engine. Usually the name will be IC engine. We will call it as a IC engine. So IC engine nothing but it is a internal combustion engine. So in that case, the fuel is burned inside the cylinder. Okay. So for example, we are using as I already told, two-wheeler, four-wheeler. So all kind of engines comes under the internal combustion engine. Okay. So already we witnessed the fuel is filled in the tank that will be moving into the cylinder. Then that will be converted into mechanical. Thereby our wheel is getting power. Then we are moving somewhere with according to the usage of fuel inside the cylinder. We are getting or we are accelerating our vehicle. Okay. So the internal combustion engine is nothing but the fuel is burning inside the cylinder. That's all. Okay. So the combustion of fuel takes place inside the engine cylinder and the heat is generated within the cylinder of the engine. So this is the example of internal combustion engine. Then according to the usage of fuel, so we need energy from the fuel. So as you know, the fuel will be different types: petrol, kerosene, diesel, even LPG, propane, butane, methane gases are also which will be used for the fuel for generating energy. So if you are considering petrol and gasoline engine, it comes under spark ignition. So later on I will tell why we are terming spark ignition engine. So the petrol comes under one separate type of engine and a diesel engine comes under different type of engine. So the petrol gasoline engine comes under spark ignition engine. With the help of spark ignition, the ignition will be take place and the pre-admitted mixture will be inside the cylinder. So with the help of the ignition, so the burning will be happen. Again the same principle. So only thing is we need to take thermal energy from the fuel, the thermal energy converted to mechanical energy. So finally we are getting some mechanical work. So here liquid fuel is atomized. So the petrol is liquid form. That should be atomized mean it should be vaporized form. Then again it should be mixed with the air. So the composition of the mixture of air and the atomized petrol, it is not a liquid form. It will be an atomized form or a vaporized form. That will be mixed with the air. Both the mixture will be entering into the cylinder with the help of spark plug. So the spark plug will produce the ignition. So with the help of the spark plug, already presence of that mixture of petrol and air that will be ignited by the spark plug. Then the burning will be take place. So initially both mixture of petrol and air coming into the cylinder with the help of spark plug, the spark plug will produce the ignition. So at the particular moment there will be a burning. So due to the burning, the energy will be converted, the thermal energy again pushing the cylinder, thereby we are getting mechanical work. So the next, so that's why we are call it as it is a spark ignition engine or a petrol engine or gasoline engine. Then come into the diesel engine. Here there is no spark plug, but instead of spark plug, we have to increase the heat inside the cylinder with the help of compression. So the the admitted diesel with air mixture entering into the cylinder, that will be compressed very huge amount of compression ratio. Due to the compression of gas, the heat will be raised due to the reduction of volume. So as you know, the gas law PV is equal to MRT. Okay, so whenever if you are reducing volume, the temperature also going higher side. So the gas molecular will be compressed, thereby we are increasing the heat content. So whenever we are applying more amount of compression, the heat energy will be raised. So once if we are attaining a particular heat, that will be burned. Then again we are getting the thermal energy converted into mechanical energy. So the converting chemical energy of heavier fuel oil into mechanical energy, the injected fuel is ignited by the heat of air, which is compressed by the piston within the cylinder heat. So in this engine, the only air is sucked during the suction stroke. So two things we have to understand. In the spark ignition engine, the entering fuel, it is a mixture of petrol and air. But in the case of diesel engine, initially the air will be sucked during the suction stroke. That will be compressed by the compression stroke. At the end of the compression, we have to spark our diesel. So once if you are already there is a presence of heat available in the air. Once if you are sparking your atomized diesel, then that will be burned. Then that will be converted into mechanical work. So that's why we are call it as it is a compression ignition engine. So due to the compression effect, the ignition will be take place. That's why the diesel engine or CI engine, or it is a compressed ignition engine. Okay. In the case of petrol engine, the burning will be take place due with the presence of spark plug. Okay. That's why we are calling it as it is a SI engine. Okay. Then I already told what is a spark ignition engine, what is a compression ignition engine. So here the working principle of what is a spark ignition engine, a mixture of air and fuel. Fuel means here petrol. So suppose you are having two-wheeler. Initially, the air and petrol mixed with the help of carburetor, that will be entered into the cylinder. Okay. Then with the help of the ignition spark plug, the ignition will be take place. Then the energy will be converted into mechanical energy. So that is called spark ignition engine or petrol engine. Okay. The mixture of air and fuel is drawn into the engine cylinder. The ignition done by a spark plug. So that's why we need a spark. So if you are witnessing all petrol engine, the important part is spark plug. Every 100 hours, every 200 hours, we need to clean the spark plug for the purpose of to provide a proper ignition. Okay. So the rapid explosion of air fuel mixture within the cylinder, when it is ignited by the spark, it is called constant volume combustion. So this is comes under thermodynamics way of working principle. Again, if you are considering compression ignition engine, air is compressed into the cylinder due to the air temperature rises from a certain level to 900 degrees Celsius. So sorry for the interruption. So actually petrol and diesel engine very easy. So if you are considering petrol engine, we have to say that is a spark ignition engine. Okay. So in the spark ignition engine, the air is initially entering into in the spark ignition engine, petrol and air mixed and both the thing will be entering into the cylinder due to the compression, and with the help of ignition, the fuel will be burned. Okay. Then the expanded gas will try to push our piston towards downward, thereby we are getting rotational effect. So then that will be transmitted through with the help of a gearbox and a final wheel. Okay. But in the case of diesel engine, initially the air is entering into the cylinder with due to high compression ratio, the presence of air getting more amount of or we are increasing the heat content, the presence of air. Then at the end of the moment, we have to spark our diesel in the form of vaporized condition, then that will be burned. So that's why we are calling diesel engine as a compression ignition engine, petrol engine, spark ignition engine. Okay. So only two differences. In a spark ignition engine, initially the petrol and air will be entering into the cylinder, but in the case of diesel, only air is entering initially, At the end of the compression, we are spraying our diesel into the cylinder with the help of injector. Okay, it's like a nozzle. Uh, 2 minutes.
Connecting in another device.
So there is some technical failure. We'll give a 2 minutes break. After we'll resume our presentation.
The speaker வந்து view ஆகலாம். PowerPoint
Okay, sorry for the interruption. Okay, all of you getting my voice and screen? Outside campus. Sir Ramjain sir, am I audible and you are getting my...
Mohan audible. Continue. Screen also visible.
Fuel combustion, that will be a spark ignition engine. Another one is a compression ignition engine. And according to the stroke, so for making this thermal energy into mechanical energy, there will be a different kind of event occurring in the engine cylinder. So based on the stroke, there will be two types. One is 4-stroke cycle engine, another one is 2-stroke cycle engine. So the 4-stroke means nothing but the movement of piston from top to bottom. That is called 1-stroke. If there will be a 4-stroke mean the piston has to move 4 times from top to bottom, again bottom to top, then top to bottom, then bottom to top. So in the 4-stroke, the force there will be a different kind of event will be happen. Thereby we are getting the output. So here when the cycle is completed in a 2 revolution of crankshaft. So I will tell how the crankshaft will be rotating based on the movement of piston. So when the stroke will be 4-stroke mean the crankshaft has to rotate 2 times. Since the 1 revolution there will be a 360 degree. So each 180 degree the piston has to move from top to bottom, again bottom to top. So there will be a 360 degree. So each revolution it will cover 2 stroke. So obviously the 4-stroke mean 360 into 360, 4 revolution, 2 revolution, that will be equivalent to 4-stroke. But in the case of 2-stroke engine, the 4 event will be occurring in a 2-stroke. So half of the crankshaft revolution, it will be completing 2 kind of event. That is, it may be a suction, it may be a compression, it may be a power, then finally exhaust. So the working principle of internal combustion engine. So as I told already, we need a fuel inside the engine and we need a ignition. Thereby we are burning our gas. That will be converted into mechanical work. So these are all the essential components to be needed to perform a engine. So the mixture of fuel with the correct amount of air is exploded or burned in an engine cylinder which is closed at one end. The heat is released and causes the pressure of burning gas to increase. So these are all the steps to be involved during the action of conversion of fuel into thermal energy. Okay. So the force is closed fitting piston to move the downward cylinder. The power is transmitted to crankshaft by the connecting rod and the crankshaft turn the flywheel. So these are the way the power is moving from fuel to piston to connecting rod to crankshaft to flywheel. Then it will go to gearbox. Finally, it will attain wheel. So these are the steps interacting when the power is generated from the fuel to it is moving towards the wheel. So for continuous rotation of crankshaft, the explosion is being repeated at a different time interval. Before this can happen, the used gas has to be expelled. So whenever you are feeding some mixture of air and fuel, it should be burned. Then the burned gas has to be removed from the cylinder. That is called removing of smoke from the engine, or we can call it as a scavenging. The expelled from the cylinder, the fresh charge again re-entering into the cylinder. The same cycle will be repeated over and over a period of time. So thereby we are getting continuous power from the engine to wheel. So the sequence of event is known as working cycle. So from one working cycle mean the fuel has to enter into the cylinder, that has to be compressed, again that has to be burned, the burned gas has to be expanded, the expanded gas transmitting the energy from fuel to cylinder, the transmitted movement converted into rotary movement that will be reaching into wheel. So these are all the event taking place during the working cycle of engine. So if you are considering 4-stroke engine, so the exam point of view, we are going to consider only two kind of engine. One is a 4-stroke engine, another one is 2-stroke engine. So both the case, the event will be happening in a predetermined time. So suppose if you are almost all the tractor currently uses what is called 4-stroke combustion cycle to convert the diesel into motion. The 4-stroke approach is also known as Otto cycle. So it is invented by the Nicholas Otto. That's why we are call it as a diesel engine, or else it is called as a Otto cycle. Okay. So there will be a 4 kind of stroke. One is suction stroke, another one is compression stroke, third one is power stroke, fourth one is exhaust stroke. So these are the stroke will be in the every 4-stroke engine or as well as 2-stroke engine. So suction stroke is nothing but we need to admit our fuel mixture of air inside the cylinder, that is called suction. So suction stroke will be happening due to the movement of piston from top to bottom. Thereby we are creating low atmospheric pressure. So when suppose for example, if you are having syringe, when you are drawing the syringe from top to bottom, the liquid will be admitting into the inside the syringe. So the same principle involved in the cylinder also. When the piston moving downward from top to bottom, it will creating less atmospheric pressure. So so negative atmospheric pressure. Thereby, due to the pressure difference, the fuel in the tank too, it will moving towards cylinder. Okay. So once the air is entering to the cylinder, in case if it is a petrol engine, we need to spray the petrol. If it is a diesel engine, if it is a petrol engine, both the mixture will be entering into the suction stroke during suction stroke, petrol as well as air. But in case of diesel engine, air only entering into the cylinder. During the end of the compression, the diesel has to be sprayed. So the suction stroke nothing but it is the entering of fuel inside the cylinder. So again, if you are considering suction, compression, power, exhaust stroke, we need to consider what is the position of valve. So valve is it like a door. When you are sitting inside the classroom, you are act as a fuel. You are entering into the classroom with the help of with the way of door. The same way the valve will acting as a door. So it will act at a particular time. Then only the fuel can enter from outside to inside. Okay. So with the help of the valve, so the valve is located at top portion of piston or top portion of cylinder. So at the right time it will open according to the stroke. Suppose initially the suction stroke will be happening. So the left side, the inlet valve will be opening. So there will be two kind of valve. One is inlet valve, another one is exhaust valve. So the valve is operating in a top side of cylinder. So initially both the valve has to closed condition. When the suction will be happening, so any one of the valve has to open. That is inlet valve. So due to the opening of inlet valve, the air mixture entering into the cylinder. The next step, we need to make compression. During the compression stroke, both valve has to be closed. Then only the entrapped mixture can be compressed. Then the end of the compression, due to the presence of spark ignition or injector, the burning will be happen. Due to the burning, the power stroke will be happen. At the time also, both the valve has to be closed condition. Then finally there is a exhaust stroke. At the time, the exhaust valve has to be open. The inlet remain has to be closed condition. So again, if you are considering a different kind of stroke, suction, the air or air fuel mixture is taken into the cylinder. The compression stroke, the charge is nothing but it is a mixture of air or fuel. Or in case suppose diesel engine mean air only mixture. So the charge is compressed in the cylinder by the piston. Then power stroke, if the charge is only air, the fuel is injected at the end of the compression. This is the example of diesel engine. Since the diesel engine only sprayed at the end of the compression. Okay. Initially the air is going inside the cylinder, that will be compressed. During the end of the compression, we are spraying our diesel with the presence of heat available in the compressed air. Then that will be converted into mechanical work. Okay. So if it is the air fuel mixture, then the spark plug has to be needed. So you have to very clear about, if you are considering a diesel engine, injector is essential to spray your fuel. If it is a spark ignition engine, spark plug is essential to give the spark. Okay, it's the electrical spark. The spark plug is given a spark plug, so the charge is ignited at a predetermined time and a specific pressure inside the engine cylinder. the power is developed due to the expansive of forces of the gases inside the cylinder that is transferred to the connecting rod and the crankshaft. So you can see the animation of this figure. So the one side of valve, it will allow the mixture of air or a mixture of petrol and air that will be moved inside the cylinder during the suction. And during the compression mean it will be the cylinder has to move from bottom to top. Then only the compression will be take place. During the compression, both the valve has to be closed condition. So due to the compression, the heat will be raised inside the charge. So at the end of the compression, we need to spray our diesel. Then explosion will be taken place. Thereby we are getting the energy. Then finally the exhaust stroke, the burned gas has to be removed from the cylinder. Then only we can, again we have to give the fresh mixture to the next event. So 4-stroke engine, all the event are completed in a 4-stroke piston. The valve for controlling the inlet of charge and outlet of charge. So the main component will control this inlet and exhaust, that is called valve. So according to the valve position, we have to know whether it is a suction stroke, whether it is a compression stroke, whether it is a power stroke, whether it is exhaust stroke. So based on the position of valve. So if you see there is a top portion, there is a two red color indicating this is a valve. So here if you are seeing the intake, so the intake, the left side valve is somewhat lower. So thereby the air fuel is entering into the cylinder. The arrow mark indicating the pistons moving downwards. Thereby the air is entering into the cylinder. So this is the first stroke. So first stroke nothing but it is a movement of piston from top to bottom. So when the movement of piston from top to bottom, the crankshaft has to rotate at 180 degree. So if you see here, so the piston moving downward from top to bottom. And also the crankshaft has to rotate half of the revolution in the rotation, that is called covering 180 degree. So each 180 degree in the 4-stroke cycle engine, the piston moving downward, it will covering 180 degree or half of the revolution. The next stroke, compression. If you see here, both the valve has to be closed condition. The entrapped fuel mixture will be compressed by again the piston. So at the time, again the crankshaft rotating next to 180 degree. So it will covering half revolution. So the for half of revolution mean one revolution. Okay. So 180 degree half revolution, another 180 degree half revolution, the totally 360 degree one revolution. The for each one revolution of crankshaft, there will be a 2-stroke. One is suction, another one is compression. So the two thing will completed. So now the presence of mixture will be has more amount of thermal energy. So the heat will be high due to the compression. When you are compressing any kind of air inside the box, it will try to increase the heat. For example, when you are the cycle pump, when you are operating your cycle pump, when the air is moving into the tube, you can feel the heat around your pump. So that is due to the compression of air. So the same principle applied cylinder also. So when the air is compressed inside the cylinder, the heat energy will be raised. So then next one, third one will be power stroke. At the end of the power stroke, again if you are seeing this, both the valve will be closed condition. The suction stroke, the inlet valve will be open, exhaust valve has to be closed. The next compression stroke, both the valve will be closed. Then third power stroke, again both the valve will be closed. Then the ignition will be happen automatically. The pressurized gas will try to push your cylinder downward. Thereby you are getting the power stroke. Okay. So you see here the ignition will be happen. Again the piston will be moving downward. Again it will getting half revolution, 180 degree. So we are completed 1.5 revolution. Then exhaust stroke, the burned gas has to be thrown outside the cylinder. For that, the piston has to move from bottom to top. Again, it is covering half revolution. Totally 4 half revolution, 2 complete revolution. Okay. So when you are considering 4-stroke engine, the crankshaft has to rotate 2 revolution. That each 2 revolution, the entire cycle will be completed. This is called working cycle of the engine. So suction, compression, power, exhaust. So each half cycle, each stroke will be happening. So the topmost position of piston, that is called top dead center. The bottommost reaching piston is called bottom dead center. Okay. The PDC, TDC, there will be a terminology will be involving in the piston. So these are the 4 steps involved in the 4-stroke engine. So what are I said the same thing will be given in each cycle. This is a suction stroke. You can see the suction stroke inward valve is open condition. Thereby the air is entering. At the time the TDC, the piston reaching top dead center, then it will try to move downwards. Then again it will reaching to bottom dead center. Thereby due to the less atmospheric pressure, the air fever entering into the cylinder. So this is a table which shows the what is the position of piston valve. So if you see here, the stroke will be suction. Am I right? The piston is moving downward. So if the piston moving downward means it may be a suction or it may be a compression. Sorry, it may be a power stroke. When the piston is moving upward, it may be a compression or it may be a exhaust stroke. But in that case, it is a suction stroke. So it is moving from top down to bottom dead center. The stroke will be suction. The piston movement, we can say it is a top to bottom dead center. What is the position of valve? The inlet will be open. What is the position of valve? Opposite valve. Exhaust will be closed condition. Then what is the action? Air will be entering or air fuel will be mixture will be entering. Suppose in case it is a petrol engine. So one thing you have to understand, the four-stroke engine or four-stroke cycle engine can be adapted in both the case, petrol engine as well as diesel engine. So it may be entering into pure air or sometimes it may be entering into the, in case if it is a petrol engine mean both the mixture can be entered. So this is a suction stroke. So can you identify the what is the figures whether it is a petrol or diesel? So you see there will be injector. Okay, so injector mean it is representing the diesel engine. With the help of the injector, the fuel can be atomized in the form of droplet. So the compressed air will be present in the compression stroke. Due to the heat, the pressurized atomized diesel become burned. Okay, so this is a suction stroke. So next one, what is the stroke? This is a compression stroke. So what is the action? What is the piston movement? Already the entrapped air inside the cylinder. What is the position of valve? Both the valve will be closed. You see here, both the inlet valve as well as exhaust valve. So inlet valve, in the inlet valve with the help of the movement of feed inside the cylinder. The exhaust valve with the help of exhaust valve, the burned gas can move away from the cylinder. So this both the valve will be for the particular purpose. Okay, the inlet valve, it will allow the mixture inside the cylinder. The exhaust valve, it will allow the exhaust gas after burning of gas. We need to remove from the cylinder. Again, we need to feed the fresh air. So this is the compression stroke. So you see the table, the stroke will be compression, piston movement from top to bottom, and the valve position, inlet side will be closed, outside will be, that is also closed, since it is a compression stroke. So the air should not move away from the cylinder. So without compression, we can't able to increase our temperature inside the gas. So action, air compressed. So next one, power stroke. So what is the position of valve? Whether it is a open condition or closed condition. Both the valve will be closed condition. Inlet valve as well as exhaust valve will be closed condition. What is the position of piston initially? What is the position of piston? Top dead center. It is actually it is a continuation of previous stroke, compression stroke. Okay. Now it is try to move downward due to the help of ignition. Okay. Now you see the injector will spray the diesel in the form of atomized form or in the form of small droplet. Then that will be mixing into the presence of air. Already the air has more heat. So once if the fuel touching to the air, it will be burned. Okay. So the burned gas will try to push your cylinder where? Top to bottom. So this is a table will shows this stroke will be power stroke. The piston movement from top dead center to bottom dead center. The valve will be, position of valve will be, both the valve will be closed condition. The action will be, diesel is injected at the end of the compression. The explosion will be take place. Okay. Now we are getting power. Okay. So the particular stroke only we are getting power. So all of the remaining stroke, the power will be given with the help of the power stroke. Okay. There will be a 4 stroke, suction, compression, power, exhaust. So only the power stroke alone we are getting the power. The remaining all 3 stroke, the power will be taken from the power stroke. So I will tell how the power will be stored in the system. So now final stroke will be exhaust stroke. Now you tell the what is the position of valve? The inward valve will be closed condition. Now the piston can move from bottom to top side. So thereby it pushing all the burned gas inside the cylinder. So due to the opening of exhaust valve, it will moving towards exhaust ports. Okay. So the stroke will be exhaust. The piston movement will be PDC to TDC. That is bottom dead center to top dead center. Then valve position will be exhaust valve will be open condition. Inward valve will be closed condition. This is the stroke, particular stroke. The event call it as a exhaust stroke. Okay. The same way, if you are considering two-stroke engine, the entire 4-stroke will be happen with one single revolution in the two-stroke engine. Okay. The two-stroke nothing but movement of stroke. The movement of piston from top to bottom, that is one stroke. The movement of piston from bottom to top, that is next stroke. So each stroke there will be a two action will be happen. One is compression, another one is, so first there will be a 4 event has to be done. Then only our cycle will be completed. We will get the power. So what are the stroke? What are the event will be happening in the cylinder? Suction, compression, power, exhaust. Okay. Without this event, our cycle will not complete. We will not get the power. So for any kind of engine, these 4 event has to be occurred. Then only we will get the power. So these 4 event can be performed by the 4-stroke engine as well as 2-stroke engine. So here only 2-stroke mean how much revolution will be happen? 1 revolution. Half revolution there will be a 2-stroke. Another half revolution there will be another 2-stroke. So the 4 event will be completed. Okay. So in a such engine, the whole sequence of event, that is suction, compression, power, exhaust are completed in a 2-stroke of the piston and 1 complete revolution of crankshaft. So crankshaft is nothing but it is a bottom portion of our shaft. So there will be a shaft bottom of your piston. So the piston moving downwards. So with via connecting rod, then the connecting rod attached to the crankshaft that will rotate in a circular motion. There is a no valve in the type of engine. The one more thing, very important thing, when you are considering a 2-stroke engine, there is no valve. Only there is a port. Via port only the fuel mixture will be entering and it is moving away. So valve means there is a movement. But in case port, there is no movement. It is a simple hole. With the help of the hole, the fuel mixture entering into the bottom of crankcase. Then it will moving via transfer port. Then it will reaching to the top of the piston. Then it will go out of the cylinder via some hole. So you can see here. So this is first one is so for example, right side the petrol air mixture is entering via port. Initially it is moving towards crankcase. The particular portion we can say this is a crankcase, bottom of the piston. So the fuel mixture entering into the bottom side of cylinder. At the time there will be a power stroke. Okay. During the suction and the power will be a simultaneous stroke, simultaneous event occurring in a half stroke, a single stroke. Okay. Half revolution of crankshaft. Then next thing will be exhaust and compression. So initially suction plus power stroke will be happening. Next stroke, exhaust and compression will be happening. Okay, I will explain those things. So here there is no valve presence in the 2-stroke engine, and also the air fuel mixture entering into the crankcase. Then it will moving sideways. That is called transport port. Then it will reaching top portion of our piston. Thereby we will if it is suppose if it is a petrol engine mean we need a spark plug. If it is a diesel engine mean we need a injector. Okay. Then there will be a port. It will leaving the cylinder final. Okay. So you see the suction and compression will be take place. Okay. So when the piston move up the cylinder, it cover 2 of the port, the exhaust port and transfer port, which is normally almost opposite to each other. So during the a single movement of piston, the suction will be initiated and also compression will be take place. Okay. So if you see here, when the piston moving upward, there will be a negative pressure created bottom of the crankcase. So once if there will be some vacuum created, automatically the air fuel mixture entering into the crankcase. During the time, the piston what is doing? It is try to pressurize the compressed fuel top portion of our piston. Okay. So here that's why we are saying suction, compression simultaneously happening a single stroke. So next stroke, power and exhaust will be happening as single stroke. So within a 2-stroke, we are completing 4 events. That is called suction, compression, power and exhaust. . So you have to remember the first stroke will be suction and compression. Another stroke will be power and exhaust. So both thing will be happening simultaneously due to the presence of single revolution of crankshaft. Okay. So next we will move into components of engines. So if you see, already I told, there will be a two thing will be operating movement of charges inside the cylinder, that is called valve. Okay. Suppose if it is a petrol engine, what we need? If it is petrol engine, what the top portion has to be connected with the spark plug. Suppose it is a diesel engine, mean fuel injectant. And the next thing is a piston. The piston is surrounded by the cylinder. Okay. So the inside the cylinder only all the event will be taken place. Okay. The cylinder again piston. The piston moving downwards due to the explosion of gas during the power stroke. Am I right? So when the fuel is burned, that will try to push your piston downward. So the piston moving downward, that is connected to the connecting rod. So we need some connection between the crankshaft. So this rotation will be taken place the bottom of engine, that is called crankshaft. So crank mean rotating. So automatically it will rotate the shaft. So that is why we are saying this is a crankshaft. So the crankshaft connected to the piston with the help of what kind of shaft? What kind of rod? Connecting rod. Okay. So there is a cylinder. Inside the cylinder there is a piston. The piston moving downward with the help of gas, but explosion gas. The power is transmitted via connecting rod. The connecting rod connected into crankshaft. So these are all the components of with respect to the engine. Okay. So apart from that core component, there is a cylinder head. So we need to cover the entire system. For that we need a cylinder head and also cylinder block. So in the cylinder block, suppose if it is a single cylinder engine, there is a small component. If it is a 3-cylinder, 4-cylinder, when you are considering bigger horsepower tractor, bigger horsepower automobile, for example car, so it may be a 3-cylinder, 4-cylinder. So if you want to control the heat, the surrounding of engine, we need to provide a cooling system. So for that we need a engine block. So the cylinder block will accommodate all the components inside the cylinder. Okay. Then there will be a valve. So with the help of the valve only we are allowing mixture inside the cylinder as well as leaving the gas from the cylinder. Then gut joint bin. So the gut joint is nothing but it is connecting the piston and the connecting rod. So we need some kind of device to connect, to arrest the piston and the connecting rod. Okay. The major components will be piston, connecting rod, crankshaft. The minor component are gut joint pin. It is like a small rod which is connecting both the piston and connecting rod. Then we need some kind of valve to make some compression in the inlet valve. Then tapered valve. Then again, if you are seeing here, so the connecting rod connected to where? Crankshaft. Okay. So via crankshaft only the entire power moving backside of rear wheel. Okay. Again, there is an important component, flywheel. So I already told we are getting only power. Which stroke? There will be a 4-stroke. We are getting only outcome. Which stroke? Power stroke. The remaining stroke has to be done by the system. At the time, the stored energy of flywheel will deliver the power. So initially the suction will be happening. How does it will be happen? It has to move from top to bottom. The power will be coming from where? Flywheel. Okay. So initially during the power stroke, the entire source of power will be stored in a flywheel. The remaining 3 stroke delivered by the flywheel. So the flywheel also connected with the crankshaft. The end of the crankshaft, there will be a flywheel. So if it is a single cylinder diesel engine, you see this is a flywheel, a big wheel rotating with the crankshaft. So these are the components of the parts of the internal combustion engine. And terminology related to the engine. So if you want to give some terminology with respect to the cylinder. So bore mean, what do you mean by bore? It is nothing but it is a diameter of cylinder. Usually when you are going to buying a 2-wheeler, 4-wheeler, usually it is expressed in terms of cc. Am I right? What is your cc of bike? What is the cc of your car? For example, 150 cc bike we are having, 120 cc. The CC is nothing but it is related to this bore and stroke. So bore is nothing but is the diameter of cylinder. If you are measuring with the help of scale, what is the diameter of cylinder? That is called bore. Okay. So bore is nothing but it is the diameter of cylinder or piston. So what is the unit of diameter? What is the unit of diameter? It may be a centimeter, it may be a meter. It is a distance. Okay. So the diameter is nothing but it is a length of our cylinder. We want to measure what is the size of your cylinder. Then we can say what is the capacity of your cylinder, whether it's a 150 cc, whether it's a 120 cc. Okay. So this is a bore, diameter of engine cylinder. What is the stroke? Already we discussed it. What do you mean by stroke? What do you mean by stroke? Movement of stroke from top to bottom. That is what is the distance it is covered from top to bottom. That is called stroke. The linear distance traveled by the piston from top dead to bottom dead center. So once the piston moving from top to reaching bottom, that is called stroke. That's all. Okay. The stroke bore ratio. So we are comparing whether which one is the higher side, whether the bore will be high or stroke will be high. So we are comparing. So stroke bore ratio is nothing but it is a ratio of length of the stroke divided by bore of your cylinder. Okay. So what is meaning the stroke bore ratio? So usually which one will be higher side? Whether the diameter will be higher side or a stroke will be higher side? Stroke will be higher side. That's why we are getting 1.45, 1.25 ratio. When you are designing your engine, the stroke bore ratio has to be within the range of 1.45 to 1.25. Okay. Okay. This is nothing but if the diameter of cylinder is 1 meter, mean what is the stroke of our cylinder as to 1.45 meter. If it is a 10 centimeter, mean it is a 14.5 centimeter length. Okay. This is the concept of the bore stroke ratio. So it is a ratio between the 1.25 to 1.45. Then swept volume. Now we measured what is the diameter. Now we measured what is the length. With the help of the diameter, we can able to find out the area of circle. What is the area of circle? What is the area of circle? Pi r square. With the help of diameter, you will know what is the area. If you know the area, if you know the stroke, will it possible to measure volume? Yeah. Is it possible? When you are multiplying area into length, you will get the volume. So that is called the swept volume. This volume we are representing cc. So if you know what is the diameter of cylinder, if you know what is the stroke of cylinder, you can easily find out your cc of your engine. So thereby you know whether it is a small engine, whether it is a larger size engine, we can easily understand. Okay. So are you understand what is swept volume? What do you mean by swept volume? Volume occupied by a piston. The piston is moving from top to bottom. How much amount of volume it will cover? Okay, that can be calculated from the diameter of piston. With the help of diameter, we are converting area. When you are multiplying stroke length, we are getting volume. That's all. Okay. So this you can see the side view of your engine. So there is a inlet manifold, exhaust manifold, or valve. Then there is a clearance volume. You must be understand the piston never it will reach the topmost point of your cylinder. There will be a small clearance between at the topmost cylinder to piston. That is called clearance volume. So it will reach a particular height only. Then remaining portion will be stroke. That is TDC to PDC. So the entire volume, if you want to find out the entire volume, we need to measure clearance volume as well as swept volume. So swept volume is nothing but it is the length of the stroke, and if you are multiplying the area of the stroke volume, you will get the swept volume. When you are adding clearance volume, you are getting total cylinder of volume. Okay. So this is a top dead center, this is a piston. So there will be a clearance will be there. The particular volume we are saying that is a clearance volume. So compression ratio. What do you mean by compression ratio? During the compression stroke, the air fuel or air is compressed by the piston. So that can be termed in terms of some ratio. If it is a 14 amount of fuel is entering in the cylinder, that will be compressed into 1 part. Okay. Suppose if it is a 14 meter length of air entering into the cylinder, that will be compressed into 1 meter length. So that much amount volume reduction will be happen. So that is called compression ratio. So what is the compression ratio of diesel engine? 14:1 to 22:1. Okay. So in case if you are seeing the petrol engine, the compression ratio will be 4:1 to 8:1. Much means lesser than the diesel engine. That's why the diesel engine, it won't require spark plug. So that much of amount of compression will be created during the compression stroke. So with the presence of this much compression, the enough heat will be generated inside the gas. So thereby you have to spray your fuel, then explosion will be take place. So in petrol engine, the compression ratio will be 4:1 to 8:1. So when you are comparing compression ratio, the compression ratio will be high in case of diesel engine, whereas petrol engine it will be less. Since we are having, what is the reason we need to create this much compression? The ultimate thing is we need to create temperature or heat inside the cylinder. Then only the explosion will be take place. For that only the diesel engine has more compression ratio when compared to petrol engine. Since the petrol engine has spark plug, so there is no need of that much compression. Okay. So that's why the diesel engine has more weight when compared to petrol engine. When you are considering petrol engine vehicle, diesel engine vehicle, the diesel engine has robust, large size, and also it is more weight when compared to petrol engine. That's why the cars and all we are preferring petrol engine. It will give more speed when compared to power ratio. Then power, as you know, the power will be rate of doing work. The unit will be watt or so already stated what is mean by power. What do you mean by 1 HP? A horse can lift the 75 kg of mass at a height of 1 meter within a second or 1 second. That is called HP. 75 kg meter per second. If there will be happen, that is called 1 HP. So if you are converting kg into Newton, you will get the 746 watt. Okay. So horsepower, 1 horsepower is nothing but it is a 75 kg meter per second or 4700 kg meter per minute. So this is a unit conversion. So the application you already know, it will be used in all kind of activities, not only agricultural aspect. So construction equipment, automobile, civil engineering. So these are all the difference between you already know everything. So what is the difference between 4-stroke and 2-stroke? So which thing will be available in or what kind of rotation will be happen? Based on crankshaft rotation, you tell. In the 4-stroke, the crankshaft will rotate two revolution. But in the case of 2-stroke, so this is a major difference between the 4-stroke and the 2-stroke. And also, what is the power generated? So if in case of 1 power stroke for every 2 revolution of crankshaft, this is known thing. Since it is a 4-stroke, there will be a 1 power stroke. So it has to rotate 2 times. But in case of a 2-stroke engine, 1 power stroke will be each revolution of crankshaft. It is right now. So each revolution of crankshaft, we are getting 1 power stroke in the 2-stroke engine. But in the case of 4-stroke engine, it has to rotate 2 times. Then only we are getting 1 power stroke. There are inlet exhaust valve in the engine. There are inlet exhaust port inside the valve. So already I given one more difference between the 2-stroke, 4-stroke. In the 4-stroke, which device will allow the fuel? Valve, inlet valve, exhaust valve. But whereas in the case of 2-stroke engine, port, or it is simply we can say hole. So there is no valve presence in the 2-stroke engine. So the crankcase is not fully closed and airtight. But whereas in the 2-stroke engine, the crankcase, that is bottom of the engine. Since the fuel is entering in the bottom of your cylinder, it must be airtight. It should not be a leak any from outside. So it should be airtight. So in case of 2-stroke engine, it's airtight. Whereas in a 4-stroke engine, it may not be airtight. The top of the piston compresses the charge. Both the side of piston compress the charge. It is right now. In case of 4-stroke engine, during the compression stroke alone, the fuel is entering in the top portion of piston, that will be compressed. Whereas in a 2-stroke engine, both the side will be, fuel will be going. Bottom side also through the transfer port, then it is reaching top side. So both the side, the compression will be taking place. Then the size of the flywheel is comparatively large. In case of 2-wheel, it is comparatively less. Since the power will be delivered in a 1 revolution of crankshaft, whereas in a 4-wheel drive, 2 revolution of crankshaft. So remaining and all construction wise difference. What is the weight engine per HP? What is the thermal? Which one is thermal efficiency high? Four-stroke engine. Since the off revolution of crankshaft, the fuel is being present in the cylinder. So the entire it will be burned. But in the case of whereas in a two-stroke engine, it is partially burned. So it is off of the fuel without burning, it will moving away from the cylinder. So the thermal efficiency of two-stroke engine will be less when compared to four-stroke engine. The removal of excess gas is easy, but whereas two-stroke engine very tedious. So partial amount of air will be mixing in a fresh gas, as well as the remaining will be going downside, outside. So the torque produced is even, whereas a two-stroke engine torque produces is the less. So these are the comparison between the four-stroke and two-stroke. So this is a special already we discussed what is the compression ratio of diesel engine, what is the compression ratio of petrol engine, how much amount of pressure is being built in the during the compression. So this is a 30 to 45 kg pressure will be created. The same way we can compare diesel and petrol. What is the major difference between diesel and petrol engine? Yeah, spark must be required for petrol engine. Injector must be required. Okay. So what is the compression ratio of petrol and diesel? Compression ratio for diesel 14:1 to 22:1, but in whereas in a petrol engine 5:1 to 18:1. Here the diesel is fuel, where the petrol is fuel. The only is air sucked during the suction stroke. In a diesel engine, the air alone it is entering into the cylinder, but whereas in a petrol engine, both the air and fuel will be mixed with the help of carburetor. The particular device we will name it as a carburetor. The carburetor will do the function of mixing of air and petrol. Okay. So here the fuel injection pump is required, where the carburetor ignition is required. So the thermal efficiency for the diesel engine around 32 to 38%, whereas thermal efficiency of petrol engine around 25 to 32%. Thermal efficiency, I already told, the entire fuel will not be burned, the entire heat will not be converted into mechanical work. A partial amount of heat only converted into mechanical work. So in the whereas of thermal efficiency of diesel engine, 32% of your fuel will be converted into mechanical work. Okay. So these are the comparison between diesel and petrol engine. So this is so entire lecture about the working principle of four-stroke, two-stroke, and a terminology related to the engine, and a difference between the two-stroke, four-stroke, as well as petrol engine, diesel engine. Okay, any doubt related to this chapter? And also I request outside campus also can raise your question if you have any doubt. உங்களுக்கு புரிஞ்சதா புரியலையா? Any doubt இருக்கா ஏதோ? Sir Ramji sir, is it any doubt from your side, from the student side? Kamaraj sir, Joshua sir. Sir Ramji, is it audible? Are you getting my voice, sir? Is it any doubt?
Audible, Mohan.
Audible, audible. Sir, if you have any doubts, please ask students.
Good morning, sir. Good morning, sir.
Students,
Good morning, sir. Myself, Space India from Ichangote College, sir.
So, Joseph sir, any doubt among your students?
Good morning, sir. Myself, Space India from Ichangote College, sir.
Ma'am, yes.
Sir, I have a doubt. How much temperature when power generated, sir?
how much power generated.
Yes, sir. How
So it
much
is-
temperature will be there in power generated, sir?
How much power? Temperature around it is 3000 to 2000, 2000 to 3000 degree will be raised during the power stroke.
Okay, sir. Thank you, sir.
And also the power will be, it is related to the stroke bore ratio and swept volume of your cylinder.
Okay, sir. Thank you, sir.
So any other campus, sir? Is it any doubt?
Hello, Mohan Kumar.
Sir, yes, sir.
Yeah. Here one of our student will ask some doubt.
Sir, can you tell me the example of four-stroke engine, sir?
So four-stroke engine, it is available everywhere. Even if you are taking our tractor in our field or even your farm also, it is example of four-stroke engine. So the four-stroke engine, it can be witnessed by the seeing of injector, fuel injection pump. Thereby you can know that is a four-stroke engine. If there is no fuel injection pump, there is no injector, we can say that is a two-stroke engine.
Thank you, sir.
So generally, in general, all the heavy vehicle, it is preferred for four-stroke engine, four-stroke as well as diesel engine. If you are using a small kind of tools or equipment, it is comes under a two-stroke petrol engine.
Thank you, Dr. Mohan Kumar.
Thank you, sir.
Sir, why we cannot use sparklets for diesel engines, sir?
What?
Why cannot we use sparklets for diesel engines, sir? Only for petrol engines we are using sparklet. Why cannot we use
Property of diesel and petrol. If you are feeding the instead of petrol into the diesel engine, it will pre-burn. So the the burning characteristics will be varying with the petrol and diesel. So it is related to more property of your fuel. So thank you one and all for giving this opportunity. I thank our Dean SPGS and as well as our Dean Agri for giving this opportunity. So I close the session. Thank you one and all.
So the remaining questions you can ask in the coming classes. Reserve the questions for the coming classes. Due to the lack of time, we close the session. Next class onwards, we try to finish exactly by 11:30. Okay, including the session because you are waiting for next classes is going to start next. So thank you. Thank you for all the online participants, all the colleges, deans and coordinator. Thank you. We'll meet again tomorrow by 10:30. But the connection will be checked by 10 o'clock itself. Please, all the other colleges, please try to ensure your connection by 10 o'clock itself. Thank you.